We are doing carbon and compounds chapter, and today we will be discussing structure of diamond and graphite, which are two allotropic forms of carbon. So what is the condition in case of diamond? Diamond is having one carbon atom attached to four other carbon atom with the help of four single covalent bond, and each covalent bond is equally strong. Okay, and in this way every carbon is connected to other four carbon and in 3D structure, and we will get a very rigid 3D structure of diamond, because of which diamond is one of the hardest substance known. So the point which we have to remember in this case is that carbon is forming four covalent bond which satisfies the tetravalency of carbon. Now in case of graphite, each carbon is bonded to three atoms in the same plane, giving hexagonal array. So here one carbon, this is one carbon, it is connected to three other carbon atoms with the three covalent bond. Sometimes you may get one of the bond as double bond, but the fourth electron is most of the time freely available on the every carbon. So every carbon has got three covalent bond, and these carbon atoms are so arranged to give hexagonal rings. These hexagonal rings are connected together to give you a layered structure. Now one layer of hexagonal ring is placed over other layer, and these two layer, they have very weak force of attraction, which is much weaker than the covalent bond. So the basic difference between diamond and graphite is that in diamond all bonds or all attractive forces are very strong, which are covalent bonds. While in case of graphite, in the same plane, carbon forms bond with three atoms. These bonds are covalent bond, but in between different layers, we have wide gap and we have weak force of attraction, or we are having weaker intermolecular forces. And because of this weak force, one layer can slip over other, and your graphite is very soapy and slippery in touch, and every carbon can make available fourth electron as a free electron, which is responsible for electrical conductivity of the graphite. So this is the basic difference. One is hard substance, the hardest known substance. Another one is very is crystalline, but it is very soft, soapy in touch, and easily can be broken. And this is the bad conductor, while this one is a very good conductor of electricity because of the availability of free electron, which is fourth electron on every carbon. Okay, always remember, fourth electron may form a double bond, but it is easily available on every carbon. Now come to the NCERT question on page number 61. They have given what would be the electron dot structure of carbon dioxide. Carbon dioxide formula they have given CO2. So first we will write down one carbon atom as given in the formula, and the carbon has got four valence electron. So we will show here four valence electron of carbon. Now we are having two oxygen atoms. So first oxygen atom, it is having how many electrons? 6 electron. Oxygen has got 6 valence electron, because in second shell oxygen have 6 electron. Okay. Now oxygen will share 2 electron of the carbon, and in doing so it will get octet condition, same with the other one, while your carbon in the center will share 2 electron of first oxygen and 2 electron of the second oxygen. So 2 plus 2, it will be getting 4 electron, or sharing 4 electron from 2 oxygen atom. So if we look in the shared area, here 2 electron pairs are shared, here also 2 electron pairs are shared. Therefore we have carbon in the center and double bond between carbon and oxygen are having 2 pairs of electron which are not used in bonding. They are called as lone pairs. This one is your lone pair of electrons. So every carbon is having 2 lone pair of electron. So this is the electron dot structure of carbon dioxide. In the next question, we have what would be the electron dot structure of sulfur, which is made up of 8 atoms of sulfur. So we have to depict here how many atoms? 8 atoms. Sulfur exists as S8 molecule. So we will show 8 atoms. 1, 2, 3, 4, 5, 6, 7, 8. These are 8 sulfur atom. Now each sulfur has got 6 electrons just like oxygen. So we will show 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Same for the next one. Every sulfur is having 6 electron. So valence electrons are 6 in sulfur. So this is how electrons are arranged. We will write down electron in a way that it will be easy for you to show the overlap in the electron dot structure. This is how 8 sulfur atoms are arranged with their electron. Now every sulfur atom will share 1 electron each from each sulfur atom, which is the neighboring sulfur, and on each side it will form 1 covalent bond. Same is the case here for the second one. Same is the case for the third one. Then we have for the fourth one. We have for the fifth one. Then the sixth carbon atom in the same manner, 1 bond on one side, 1 bond on other side. And we have for the next sulfur the same type of sharing, and for this sulfur we are having sharing. So this is how every circle, make sure every red circle is having 8 electron to show the octet, and in between sulfur atom everywhere a pair of electron is shared. Have a look here, 1 pair here, 1 here, 1 here, 1 here, and so on. So single bond is formed between sulfur atoms, and we can show in this this arrangement how the shape of the molecule will be there. So 1 sulfur atom, second, this is third, and we are having fourth, this is fifth, then we have sixth, this is seventh, and this is 8. So this is a twisted ring structure for S8 molecule, and this is the electron dot structure of S8 molecule. Now next is versatile nature of carbon. We have discussed earlier that carbon form millions of compounds, and total number of compounds which are formed by carbon, they are much more than the compound formed by all other elements. Yes, carbon compounds outnumber by a large margin the compound formed by all other elements. Why? This is why, because carbon form variety of compound and number of compounds is very large. That is, millions of compounds of carbon are possible. But question arises, why? This versatile nature of carbon is because of 2 reasons. First reason is catenation. What is catenation? Self-linking property of atoms. Have a look here in the S8. 1 sulfur atom is connected to 2 sulfur atom, and in doing so, we are having a ring of 8 sulfur atoms. So here maximum 8 sulfur atoms are connected end to end. But in case of carbon, we can connect very large number, that is 100 of carbon atom, to form a chain of carbon atom or branch chain of carbon atom or a ring of carbon atom. And in addition to that, carbon can form such type of structures either with single bond or double bond or a triple bond. Have a look here, 2 straight structure for double and the triple bond. Okay. So first reason is catenation, that is self-linking property is maximum in case of carbon. No other element have catenation to this extent as in case of carbon. Now, if you see all these compounds, first 3 are having only carbon-carbon single bond. So when we have only carbon-carbon single bond, we call such compound as saturated compound. So first 3 compounds are saturated. That is your first, second, and third. these are saturated compound. But if we see in case of your fourth structure and the fifth structure, in fourth structure we have a single carbon-carbon double bond, and here we have carbon-carbon triple bond. So fourth and fifth are unsaturated compound where we have at least one carbon-carbon double bond or carbon-carbon triple. Remember, when all bonds are single, it is saturated. But if at least one is double or triple, so in addition to double or triple, we can have single bond also. Fine. So, but even if one double is there or one triple is there, then it is called as unsaturated hydrocarbons. So, these two are the examples of unsaturated hydrocarbon. Now, in all these cases, whether carbon forms saturated compound or unsaturated compound, it forms straight chain, branch chain or ring, whatever is the molecule carbon forming, all carbon-carbon bonds are very strong and they are very stable. Second reason for exceptional behavior of carbon is tetravalency. That is, carbon has got in K shell 2 electron, L shell 4. So valency is 4. It needs 4 more electron to complete the octet. So carbon can form 4 covalent bonds with other carbon atom, or it can form with other atoms also, like hydrogen or chlorine. In addition to this, it can form bond with other type of atom like oxygen, sulfur, nitrogen and chlorine. Okay, and therefore we get a very different variety of compounds, and in every case the thing which is important to remember is that carbon form very strong bond. Why carbon is able to form a very strong and stable bond? Reason, because it has small size and its nucleus can hold shared electrons very strongly. Any other atom may have size smaller than carbon or bigger than carbon. So therefore, in those cases, nucleus is not able to hold electron as strongly as in the case of carbon. Therefore, carbon covalent bond formed by carbon are very strong. Okay, so these are the two reasons for versatile nature of carbon, that is catenation, self-linking property and tetravalency. Now here we have discussed few examples of saturated and unsaturated compound. Now let us have a look on electron dot structure of few saturated and unsaturated compound as we discussed earlier. And the first one in this case is ethane. With the molecular formula C2H6. In the formula, there are 2 carbon atoms. So we will show here 2 carbon atom. And as you know, carbon has got 4 electron in the valence shell. So we will depict 4 electron. Now there are 6 hydrogens. So per carbon atom, there are 3 hydrogen atoms. So we will arrange 6 hydrogen in such a way that each carbon is getting 3 hydrogen. Okay. Now we will show how electrons are shared. Hydrogen is having 1 electron, so it need 1 more electron to get stable configuration of the nearest noble gas, which is helium. So first shell can accommodate only 2 electrons. Therefore, hydrogen will share 1 electron of carbon, and each hydrogen is getting stable configuration or getting satisfied. Now carbon need 4 electrons, so it will share 3 electron from 1 from each carbon, and 4th electron it will share of the neighboring carbon. Same is the case for the second carbon atom, and in doing so we are having 1 electron pair being shared between 2 carbon atoms. So we can show here we are having carbon-carbon single bond. Why carbon-carbon single bond? Because 1 pair of electron is shared between 2 carbon atoms, and we are having single bond between each carbon and respective hydrogen atoms. So this is ethane molecule, and this is the electron dot structure of ethane molecule. Now second one is ethene. And ethene has got 2 carbon atom again. So we will show 2 carbon atoms. 1, 2, 3, 4. 4 electron on each carbon. Why I have written show electron like this? It will be clear when we'll show the structure. Now there are total 4 hydrogens. So per carbon there are 2 hydrogen. First hydrogen and second hydrogen. Same is the case for other one, first hydrogen and second hydrogen. Now we'll satisfy. Now carbon is in a need of 4 electrons. So 2 electron it will share for from 2 hydrogen atom, but it need 2 more. Therefore it will share 2 electron of the neighboring carbon atom. Same is the case for the second carbon atom, that is it will share one electron with 2 hydrogen and it will share 2 electron of the neighboring carbon. Now hydrogen will get satisfied as earlier, that each hydrogen will get stable configuration of helium, that is 2 electron in the valence shell. In doing so, we are sharing 2 pairs of electron. Therefore here what we have, we are having carbon-carbon double bond, because 2 pair of electrons are shared, and we are having 2 bonds with the 2 hydrogen atom, because total 4 hydrogen are there. So this is your ethene molecule. Now next one is your ethyne. Okay, so how to show ethyne? In ethyne, we are having 2 carbon and 2 hydrogen. So we will show here 2 carbon and 2 hydrogen. So per carbon we have 1 hydrogen. As a result, separately we'll show only 1 electron, and this is how we will be showing electron in this case. And then we will show hydrogen atom. These are the electrons of hydrogen atom. Then hydrogen will get satisfied as earlier, as we did in the earlier case. Now each carbon will share 1 electron from hydrogen. So it is in a need of 3 more electrons. So it will share 3 electron of the neighboring carbon. Same is the case for the second one. Now in this case, in between the carbon atom, 3 electron pairs are shared. Therefore, we are having carbon-carbon triple bond. Okay. And in this case, hydrogen, if we want to show, then we have 1 bond with 1 hydrogen atom and another bond of the second carbon with another hydrogen atom. So these are 3 molecule electron dot structure of 3 compounds of carbon. First one, as we have shown, where we have all single bond, this one is saturated one, while the second and third, they are the unsaturated compound. These 2 are the unsaturated compound, while the first one is the saturated compound, because all carbon-carbon bonds are single. Now we can classify your carbon compounds on the basis of type of bond, as we did earlier, saturated and unsaturated, but we can do on the basis of arrangement of carbon atoms, so that we can get a chain or a branch or a ring of carbon atoms. So for this classification, on the top I have written here hydrocarbon. What do you mean by hydrocarbon? Carbon and its compounds are also named as hydrocarbon. Why? Because main element which are present here are carbon and hydrogen. So hydrocarbons are basically compounds of carbon and hydrogen indirectly, which are carbon compounds. So carbon compounds can be called as organic compound, and they can be called as commonly hydrocarbons. Now hydrocarbons are of 2 types. First type is saturated, and your first type is saturated and the second one is unsaturated. When we have only carbon-carbon single bond, then it is called as saturated. But if we have a double, at least 1 double or 1 triple, then it is called as unsaturated. Now the unsaturated one, they are called as alkanes, while the unsaturated one with double bond are called as alkene, and with triple bond are called as alkyne. So basically hydrocarbons are of 3 types: alkane, alkene and alkyne. Now each type can be further divided into different types depending upon how carbon atoms are arranged to give different shapes. So the first one, if your carbon atoms are arranged end to end to give a straight line, it is called as a straight chain alkane. If we are having one or more branch, it is called as branch chain alkane. And if all carbon are arranged in the form of a closed ring, it is called as cyclic. Okay, now similar type of classification we can give for alkenes also. Alkenes can also be of three type. Alkene may also be straight chain alkene, branch chain alkene, or cyclic alkene. In the same manner, alkyne can also be of three type. Alkyne can be straight chain alkyne, branch chain alkyne, or cyclic alkyne. Okay. Next topic is structural isomers. Okay, structural isomers. What is structural isomer? So a compound with identical molecular formula. Identical means different compound or which are having the same molecular formula but they have different structures. Structure means arrangement of carbon atoms. How carbon atoms are connected. They are called as structural isomers. Now have a look here in first two examples. So it will be clear from first two examples that what are structural isomers. So in the first example, carbon atoms are arranged end to end in a straight line. Have a look here. 4 carbons are arranged. Okay. And in this case, 3 carbons are arranged and end to end to give a straight line, and 1 carbon is present in the form of a branch. Okay, but in both the structures, first and second, how many carbon atoms we are having? We are having 4 carbon atoms. And if we count the number of hydrogen atoms, then the number of hydrogen atoms, let us count in both the cases. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in both the cases, hydrogen atoms are 10. This compound is named as butane. We will learn how to name the compound later on. So, but you have to remember, butane with the formula C4H10 exists in the form of 2 structure. Okay. And these are structural isomers. How they different? They differ only in the arrangement of carbon atom. How carbon atoms are arranged. So structure number 1 and 2 are isomers of butane. Now come to the next structure. In the next structure, let us count number of carbon atoms. So here we have 1, 2, 3, 4, 5. Okay. In this case, 1, 2, 3, 4, 5. And in the third case, 1, 2, 3, 4, 5. In third, fourth and fifth structure, we are having all 5 carbon atoms. Okay. So we will write down the formula, molecular formula as C5. Now let us count hydrogen in each case. In these compound. So we are having hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 in third structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 in fourth structure and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 in fifth structure. So therefore, your third, fourth and fifth are isomer with formula C5H12. Okay, and this is called as pentane. Fine. So these 3 are structures of 3 structural isomer of pentane. Now have a look here in the last structure. In the last structure, also we have 5 carbon. 1, 2, 3, 4, 5. 5 carbon. So here also, if you want to write the formula will be C5 again. Now count hydrogen atoms. So hydrogen atoms are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here hydrogen are not 12, hydrogen are 10. So this is not structural isomer of pentane and it has been given name as cyclopentane. And cyclopentane is not isomer of pentane. Why? Because molecular formula is different. Okay. In classification, we are left with only one type of compound which are called as aromatic hydrocarbon. You need not to learn in detail, but you should know what are aromatic hydrocarbon. So the hydrocarbons with at least one benzene-like ring. What is benzene ring? This is benzene ring. This compound is called as benzene. What we have in benzene? In benzene, 6 carbon are arranged in the form of hexagon, or 6 carbon are placed at the 6 vertices of a hexagon. Each carbon is connected to one hydrogen and carbon-carbon bond are alternatively double and single. So this compound is called as benzene. So if any hydrocarbon is having such type of structure, it is called as aromatic hydrocarbons. So this is for now. We will continue in the next video. Thank you.